Hello everyone, welcome to Smart Intelligence YouTube channel. Today we are going to discuss CodeChef Starters 166 problems. So moving to the first problem, Merry Christmas. So Chef is planning Christmas festivities and has 3 activities to choose from. The first one is decorating a Christmas tree, which takes 1 hour, and baking cookies, which takes 2 hours, and making a gingerbread house, which takes 4 hours. Given that chef has X hours available, determine the maximum number of activities he can complete. And note that no two activities can overlap in time. So in the input format, you'll be given single integer X denoting the number of hours chef has. And the output is you need to print the maximum number of activities he can complete. So if you see the constraints, X is ranging from 1 to 10. Let us take, we are having 3 tasks. Task 1, which takes 1 hour to complete, and task 2, which takes 2 hours to complete, and task 3, it will take 4 hours to complete. So in the problem statement, it is mentioned that X is ranging from 1 to 10. So basically X is nothing but the available hours for chef. Let's say if chef is having only 1 hour, so how many tasks he can complete? He can complete only the task 1. So he will complete T1. So nothing but at max he can complete 1 task. Let's say if chef is having 2 available hours, so how many tasks he can complete? Either he can complete the task 1, which will take 1 hour, or he can complete task 2, which will take 2 hours. Can he able to complete 2 tasks? No. So either he can complete T1 or he can complete T2. So the the maximum number of tasks he can complete is 1. So when X equals to 3, he can complete T1, T2. 2 tasks he can complete, force 2. So at max he can complete 2 tasks if X equals to 3 hours. And if X equals to 4, either he can complete T1, T2. Any other possibilities? Can he able to complete 3 tasks? No. So only 2 tasks he can complete. So X equals to 5. Still he can complete either T1, T2 or T3, T1. So which will take, either he can complete T1, T2, which will take 3 hours, or he can complete 4 and 1. So either he can complete task 1 and task 3. So at max, how many tasks he can complete? 2. If X equals to 6, either he can complete T1, T2, either he can complete these 2, or he can complete task 1 and task 3, T1, T3, or else he can also complete T2, T3, or T2, T3. So at max, either he can complete T1, T2, or he can complete T1, T3, or he can complete T2, T1. So the maximum time is, the maximum activities he can complete is 2. So when X equals to 7, how many tasks he can complete? T1, T2 and T3. He can complete all the 3 tasks. So if he has 8 hours available, he can also complete 3 hours. If he has X equals to 9, he can complete all the tasks. If X equals to 10, he can complete all the tasks. So if we observe here, so if X equals to 1 or 2, either he can complete only 1 task. If X equals to 3 to X equals to 6, he can complete only 2 tasks. Here he can complete 1 task, and here he can complete 3 tasks. So X is ranging from 1 to 2, X is ranging from 3 to 6, X is ranging from 7 to 10. So if X is equals to 1 to 2, then he can complete 1. If X is equals to 3 to 6, he can complete 2 tasks. If x is equals to 7 to 10, he can complete 3 tasks. Okay, let's code it. So in the input format, you will be given x value. Okay, so first condition. So if x is equals to 1 or 2, nothing but if x is less than or equals to 2, he can complete only one task. If x is greater than or equals to 3 and x is less than or equals to 6, he can complete 2 tasks. So print 2, else he can complete all the 3 tasks. Let's run for the sample test cases. So if x is equals to 2, you need to get 1. Okay, let's submit. That's it. Moving to the next problem. The problem name is Christmas gifts. Chef is wrapping Christmas gifts for his friends. He has rectangular sheet of wrapping paper with a total area of 1000 square centimeters. Each identical gift is a rectangular box with following dimensions: height, length, and width. So to wrap a gift, chef needs enough paper to cover all 6 faces of the box with no overlapping or gaps. So we need to calculate the maximum number of complete gifts chef can wrap using the available wrapping paper. So in the input format, you will be given t number of test cases, and in each test case you will be given height, length, and width in centimeters. So you have to print the maximum number of complete gifts chef can wrap using the following available wrapping paper. So chef is having 1000 square centimeters wrapping paper, right? So you need to find out for how many gifts the chef can able to wrap the gift cover. So for each gift, you'll be given dimensions as height, length, and width. So if you observe the test case 1, you'll be given height equals to 1, length equals to 1, and width is equals to 2. So how can you find out the total number of gifts the chef can able to pack? Simple. So first we need to find out the total surface area of the rectangular box. So how can you find the total area of rectangular box? So by observing this test case 1, 2 and 3, there is a formula to find out the surface area of rectangular box. The formula is 2 into length into width plus width into height plus height into length. So using this formula, you can get the total surface area of one box. Total surface area of one box. So if you want, for how many gifts we can able to pack, the total available square sheet area is 1000 centimeter square. So to get the total number of gifts we can able to pack is 1000 divided by total surface area of one rectangular box. So using this formula, you can get the total surface area to cover one gift pack. So using that, we can find the 1000 divided by total surface area of one gift box, which will give you the for how many gifts we can able to pack the gift cover. So in the same way, test case 2, using this formula, we need to find out the total surface area of one rectangular box. So 88. So 1000 by 88, we need to do the integer division, we'll get 11. The same way for 136 for one rectangular box. So 1000 divided by 136, you'll get 7 gifts. So hope you understood the formula. Let's try to code it. So you'll be having t number of test cases. So for each test case, you'll be having 3 values: height, length, and width. So for each test case, we need to iterate the loop for t times. So first we need to find out the total surface area of one rectangular box. So TH is equals to, the formula is 2 into length into width plus width into height plus height into length. So this will give you the total surface area of one box. So to find out for how many gifts we can able to pack the gift cover is, answer equals to the total available sheet is 1000 by total surface area of one box. So print answer. So let's run it. So for this one, it is 100. So we got as expected for the sample test case. Let's submit it. That's it. Moving to the next problem, 𝗟𝗲𝗃𝗲 library. In the 𝗟𝗲𝗃𝗲 library, there is a penalty system for late book returns with the following rules. For each book returned late, penalty points equal the number of days the book is overdue. When the multiple books are returned on the same day, only the highest penalty among those books is counted. A chef has borrowed n books from the library. For the ith book, I is ranging from 1 to n. So it was returned I days late. It was returned on aith day. So you need to calculate the total number of points chef must pay. So let's understand this better using the sample input and output. So in the input format, you will be given t number of test cases. For each test case, you will be having n size of the array and you will be having n array elements. And t is ranging from 1 to 1100 and the size of the array is ranging from 1 to 10 to the power of 5 and array elements are ranging from 1 to 10 to the power of 5. So if you see the sample input and output, so you'll be having three test cases, test case 1, test case 2 and test case 3. So let's see for the first test case. So 1, 2 and 3. So let us also write the 1 based index. So 1, 2 and 3. So these are nothing but the index I value and this is nothing but the A value. So if you see in the problem statement, I denotes number of days it was late, overdue, nothing but overdue. I denotes overdue. AI denotes on which day you are returning the book. Let's see. So let's take this book was returned on day 1, day 2 and day 3. So let us write day 1, let us write day 2 and day 3. So which book was written on day 1? This book was written on day 1. So what's overdue? 1 day. So when you are returning this book on day 1, this book's overdue is 1. Day 2, you are returning this book on day 2, so its overdue is 2. You are returning this book on day 3, its overdue is 3. So if you add the overdues of all the books, you will get 6. Okay. So I hope you guys are confusing between the indices and I and AI. Let's take the second example. So in the second example, you'll be having 1, 1, 2 and 2. So these are nothing but on which day the book was returned. So if you write the indices here, 1 based indexing. So 1, this book was returned with overdue as 1 and this book was written with overdue as 2 and this book was written with overdue as 3, and this book was written with overdue as 4. So now, okay, so when you're returning this book, okay, let's write the day 1 and day 2. So basically, these two books were written on day 1, these two books were written on day 2. So day 1 and day 2. So on day 1, so this book was written on day 1. So what's its overdue? Its overdue is 1. This defines the overdue. So 1. So this book was written on day 1 and its overdue is 2. And this book was written on day 2, its overdue is 3. And this book was written on day 2, its overdue is 4. So on day 1, you're returning two books. Its overdue is one book's overdue is 1 and the another book's overdue is 2. So among this, they mentioned that you need to pay the highest overdues. You need to pay only the highest overdue amount. So nothing but among this 1 and 2, you need to pay only the penalty as 2 on day 1. So when you are returning these two books on day 2, it's one book's overdue is 3 and the another book's overdue is 4. So you need to pay overall 4 as penalty. So day 1 2 and day 2 4. So totally you need to pay 6, which is 6. Let us also see the example 3. So you'll be given 1, 1, 2 and 1, and its 1 based indexes are 1, 2, 3 and 4. Again let us write day 1, day 2, only day 1 and day 2. So in the array elements the maximum range is 1 and 2. So I'll take 1. This book, the first book was written on day 1, so its overdue is 1. And the second book is written on day 1 only and its overdue is 2. Third book is written on day 2, its overdue is 3. And the last book is written on day 1, its overdue is 4. So on day 1 you are returning 4 books and highest penalty is 4. So you will pay only 4. 4 is added. And day 2 you are returning only 1 book, its penalty is 3. So 4 plus 3, you are getting 7. So I hope you guys understood. So simply you need to find for the values for 1, 1 and 1, you need to find out the highest index of value 1. Among all the values of 1 in the given array, you need to find the highest index. So in 1, 1 and 1, the highest index is 4. So there is only 1, 2, so the highest index is 3. Simple. So here also, in both the ones, what is the highest index? 2. So 2 plus. So in 2 and 2, what is its highest index? 3, 4, which is highest 4. So you'll take 4, you'll get 6. So basically for each element, if it is repeating multiple times, you need to take its highest index value, and the index is 1 based index. So how can we solve this? We can solve this if you observe here, the maximum value in the array, it will not exceed 10 to the power of 5. So for each value of I, for each value, I'll take the maximum element in the array. I'll take one count array. I'll take one count array which will store the penalty of each value. So for the first example, let's take the second example. The maximum element is 2. So I'll declare an array of size 3. So as we are trying to access 1 based indexing, I'll take 0, 1 and 2. However, we will not use 0 index. So for 1, okay, we have the second test case here. So what I'll do, I'll take 1. So for 1, I'll go to 1 index. Initially it is 0. Initially in the count array, everything is 0. So for this 1, what I'll do, I'll go to 1 index and I'll check is this value is smaller than this index value. Its index value. If it is greater, then I'll update with 1. Next, I'll go to 1 again. So I'll go to one index, I'll check is 2 is greater than the value stored at the one index in the counter. Is it greater? Yes. So you will again update with 2. Again you'll take 2, go to 2 index in the counter. You'll check whether this 3 is greater than 0. Yes, greater. Update. Next I'll go to 2 index in counter and check whether the value stored is less than this 4. Right? So you'll update this again value with 4. So finally, the sum of all the elements in the counter is our result. Okay, let's try to implement it. So if you see, you'll be having t number of test cases. So for each test case, you'll be having n length of array, and you'll be having, let's read the array elements. List okay, so done reading all the elements. So now we need to declare the counter. So now tell me, what is size of the counter? What should be the size of the counter? The size of counter is nothing but the maximum element in the array plus 1. Because as we are using the 1 based indexing, so we need to declare the size of counter is maximum element in the array plus 1. So how can you do it? Using the max function, you get the maximum element from the array and plus 1. So I have declared a counter of size maximum element in the array plus 1, as we are using the 1 based indexing. So we need to iterate over all the elements in the array. So we need to check. So what do we need to check? We need to go for array of I, we need to go to that index in the counter and we need to check its value. If counter of a of I, if that value is less than I plus 1, because when you are storing the elements in the A array, we are having 0 indexing, so we need to check with I plus 1. If it is greater, then we need to update count of A of I is equals to I plus 1. So we need to keep on doing this for all the elements in the array. So after doing this, where is our result present? Simple. The sum of all the elements in the counter is our answer. So sum of counter. Let's run it. We need to get 6, 6 and 7. Yes, we got it. Let's submit it. Accepted. So if you observe the time complexity, it is t into n. So in the worst case, the counter size will not exceed 10 to the power of 5. And one more thing here. So instead of using counter, instead of using some empty slots, for using the memory efficient, we can also use hash map as well. So instead of directly accessing the index, we can check whether that element is present or not, and we can update the key value. There is also another way where you can try it. Moving to the next problem, costly permutations. Every Christmas, chef has a peculiar tradition of gifting a permutation p of length n. For each index I in the permutation ranging from 1 to n, there is an associated value vi. The value vi is a number of steps needed to return to index I when following this path. Start at index I, let the current index be k, then move to the index pk, continue until you return to the index I. For example, okay, so let's see this example and understand. Let's say your p array is 3, 2, 5, 4 and 1. Let us also define the indices. 1 based indexing, 1, 2, 3, 4 and 5. So for each element, we need to, let's try to find out the vi value. So how can you find out the vi value? So we need to start at index I. So let's start at index 3. So for 3, I'll go to index 3, have 5. From 5, go to index 5, having 1. Go to index 1, you're having 3. Again go to index 3, again you reach the same index. So you have started with 3 index, 5. You have started with 3 index, 3. And you have go to 3 index. At 3 index you are having 5. So go to 5. 5 go to 5 index, you are having 1. From 1 you have to go to 1 index, again you are having 3 index, again you have reached 3. So the V value here is 3. So the V3 value is 3 here. So the value for V3 is 3 here. So can I say that if this value, for this value 3, if it is 3, can I also say that for 5 is also it is 3, and for 1 is also it is 3, because if you start at index 5 also, again you will get the V value as 3. So when you have formed this path, for each and every element in this path, the V value is 3. Yes, so for 3 it is 3, 5 it is 3, 1 it is also 3. And for 2, if you take 2, you'll start from 2, again you will get 2. So what's the length of the path? It is 1. So the length of the path is 1. So how many elements are there? 2. Only one element, unique element. So its V value is 1. For 4, the length of path is 4 to 4. You'll get 1 and its V value is 1. So this is nothing but the V array. So this is nothing but the V array. Okay, moving forward, chef can perform operations to modify the permutation. In one operation, he can swap elements at positions I and j. The cost of this swap is Vi plus Vj. Calculate it before the swap. Okay. After swap, values Vi and Vj will change. So the chef's goal is to transform the permutation to achieve the maximum possible sum of all the values in the Vi array. So the chef's goal is to maximize the sum of all the elements in the Vi array. So here the sum is 3 plus 1 plus 3 plus 1 plus 3 equals to 11. So we need to maximize this value 11 using the following operations. So for each operation there will be some cost. So you can swap any elements in the P array such that if you are swapping this 2 and 4, you will get the cost as 1 plus 1, nothing but 2. Cost 2 will be added to the answer. So the end goal is you need to find out total cost required to achieve the maximum possible sum of values. So to make this sum of all the elements in the V array as maximum possible sum, how much cost it is needed. So basically how many operations you have to do. For each operation, how much cost it will take. So in the minimum cost, you have to maximize the sum of all the values in the V array. Okay, let's see. Let's take another example. Let's write the indices for this. We'll have 1, 2, 3, 4, 5, 6, and 10. So now what I'll do is I'll start from 6. So for 6, the path is 6, 1, 2. Sorry. For 6, you have to go to index 6. So you're having 3. At 3, you will go to index 3. You're having 2. You'll go to index 2. You're having 1. You'll go to index 1. You're having 6 again. This is one path. Any other paths here? So if you start from 1, 1 is already included in this path. So it value will be also length of this path nothing but it is 4, so it will get 4. This will also get 4. 2, is it present in the path? Yes, so it will get 4. For 7, is it present? No. So for 7 we need to start here. 7, we need to go to 7 index. It is having 4. Again, if you go to 4 index, again you will go to 7 index. So 7, 4 and 7. So the length is 2. Length is 2. So the length is 2, v value is 2. For 10, is it present in either of the paths? No. So we'll start with 10. Go to 10, you'll be having 8. 8. From 8, go to 8 index, you'll be having 5. From 5, go to 5 index, you'll be having 10. So the length is 3. So update the value here is 3. Now at 3, is 3 present in the first path? Yes. So what is its v value? 4. So it is also 4 here. But this 4, is it present in any one of the paths? Yes, it is present here. So its v value is 2. So I'll update 2 here. So for 5, it is present in third path. So its v value is 3. So update 3 here. For 9, 9 is not present in any one of the path. So 9 and go to 9 index, again 9. So length of its path is 1. So it is 1. So finally 8, is it present in any one of the paths? Yes, it is present in third path. Its v value is 3. So update its value as 3 here. Now, so this is nothing but v array. This is nothing but v array. Now, so what will get this sum value as? You'll get 12, 14, 17, 21, 23, 26, 27, 30. You'll get the total, the sum of all the v values equals to 30. So we need to maximize this value. We need to maximize this 30 such a way that we can perform some operations. So let's see what operations we can do, how exactly we can do. So now observe carefully here. So what's the maximum value we can fill in this v value? What's the maximum value we can fill in the v value? Nothing but nothing but the length of path. Nothing but the length of path. So what operations we can do? We can swap the elements. We can swap the elements. So let us take one element from path 1. Okay, let us define here. This is path 1, path 2, path 3 and path 4. So what I'll do is I'll take one element from path 1 and one element from path 2 and I'll swap the values. So let's take 6. I'll take 6. So I'll swap this 6 with 7. So if I swap these two values, so you'll get I'll swap 7 here and 6 here. I'll swap 7 and 6. So when you swap this, what's the cost of this operation? The cost of the operation is nothing but 2 plus 4, nothing but length of path 1 plus length of path 2, nothing but you're taking one element from path 1 and you're taking one element from path 2. So the cost is nothing but length of path 1 plus path 2. When you're swapping one element from path 1, one element from path 2, the cost is nothing but length of path 1 plus length of path 2. Now, what happens when you have swapped one element from path 1 and one element from path 2. So when you have swapped it, when you try to find out the path now, let's see what happens. You'll start with 7. You'll start with 7. So go to 7 index. You'll be having 2. Okay, let us also write here. From 7, you'll go to From 7, you'll go to 7 index, you'll be having 4. You'll be having 4. From 4, go to 4 index. Go to 4 index. You'll be having 6. The updated value is 6. You'll be having 6. Again from 6, go to 6 index. You'll be having 3. So from 3, go to 3 index. You'll be having 2. You'll be having 2. From 2, go to index 2. You'll be having 1. From 1, go to index 1. You'll be having 7. You'll be having 7. So if you observe here, what's the length of this path? 1, 2, 3, 4, 5 and 6. So when you have swapped one element from path 1 and one element from path 2, the newly updated path value is, the newly updated v value is 6, nothing but length of path 1 plus length of path 2. So can I say that? Now for 6, the newly updated value is 6. For 1, it is 6. For 2, it is 6. For 7, it is 6. For 10, it is 3. For 3, it is 6. For 4, it is 6. For 5, it remains same. 9, it remains same. 9, 8, it remains same. So when you have swapped one element from this path and one element from this path, these two paths got merged and converted into one bigger path, so that all the v values in the bigger path will become 6. So now when you add these v values, you'll get sum greater than 30. So we understood one thing, that if we can merge all these paths into one path, you'll get the maximum possible value of v value. The maximum possible value of v in all the elements. Nothing but you'll get all the v value as maximum. Nothing but length of array. So the thing is, how will you merge these paths? Okay, let us move forward. So when you have done this, when you have merged path 1 and path 2, you got this path. Now I'll merge this one. So till now, when you have merged path 1 and path 2, nothing but swapping the elements. What is your cost till now? 4 plus 2, 6. To merge path 1 and path 2, you got cost as 6. This is the newly updated path. So when you swap one element from newly updated path, new path, and path 3, do you know how much cost it will take? 6 plus 3, nothing but 9. It will take the cost as 9. So when you swap these two, when you merge path 1, path 3 and newly updated path, do you know what you'll get? It will get combined into one single path. So it will start with some element 10 and it will end with 10. So what is its length? Simple. 6 plus 3, 9. You'll get 9. So when you merge path 4 and newly found path, 1 plus 9, 10, it will take 10. So when you merge this, it will start with 10 and finally it will end with 10. So finally you have converted it into one path. So length of v value is 10, and for all the elements in this path the v value is 10. It's a max value. So how much cost it took to merge all these paths? It is nothing but 15 plus 10. It took 25 units cost to merge all these paths. So now observe carefully here. This is the optimal way of merging this path to get the minimum cost. First, I have merged path 1 and path 2. Again, I have whatever the new path I got, I have added this path 3, and whatever the result I got, I have added path 4. Is it a better way always, or is it an optimist way? And also here, is it really required to write all these paths? Is it really required to write all these paths? Because the end goal is we need to find out this cost. So how can we get the cost? If we have the lengths of paths, we can easily get the cost. So in the path 1, first its cost is 4, 2, 3 and 1. Okay, so 4, 3, 4, 2, 3 and 1. Path 1, path 2, path 3 and path 4. So when I merge these two, you'll get 6. New path, its length is 6. So how much it cost? 6. Nothing but 4 plus 2, it costs 6. Now, you'll merge this 6 and 3. What you'll get, the new path length is 9. So you need to add 9 to it. Next, when you add this new path and 1, you'll get new path length as 1. There is only one path. V value is 10. It is 10. So again you got 25 here. So if you have the lengths, it is sufficient to get the total cost to convert or to merge all the paths. Now moving forward, so is it the optimal way of merging this, or any better way of doing it? Is there any better way of merging all these paths such a way that the cost is less than 25? Let's see. So instead of merging like this, what I'll do is I'll sort this. So you'll get 1, 2, 3 and 4. So first I'll take 1 and 2. So if you merge this path 1 and path 2, how much cost it will take? 3. 3 plus, when you merge 3 plus 3, you'll get 6. Add 6. 6 and 4, you'll get 10. So you'll add 10 here. So how much cost you got totally? You got 19 here, which is less than 25. So is there any better way? This is a better way. So to merge all the paths and to get the maximum value of v value, so the cost required is 19. So the output for this example is 19. So I hope you guys understood. So if you observe here, what we are doing always. So I have taken 1. So first I have taken 1 and 2. These are the minimum values among all the lengths. I have taken the minimum values of all the lengths and I have added. I got 3. So among these 3, what are the minimum values? 3 and 3. So I have taken 3 and 3. We got 6. We have only 2 values and have added 6, 4. You got 10. So each time when you are merging, you need to add that value to the cost, which is our result. So we understood that always we need to pick the minimum and we need to add it. So what if, let's say for sample test case here. So for 2, if we start with 2, 3 and 1, indexes are 1, 2 and 3. So starting with 2, go to index 2, you'll be having 3. Go to index 3, you'll be having 1. go to index 1, you'll be having again 2. So how many paths exist here? There is only one path and its length is 3. So all its values are 3. So the maximum value we can achieve is 9. So do we need to merge any paths here to maximize this? Can we maximize this 9 value? We cannot, because already it is in the single path. So all its values are maximum. So no need to merge anything. So when you are having only one path in the given array, answer is 0. Let's see for second test case. So 4, 2, 1, 4, 1, 3 and 2. So let 1 base indexing 1, 2, 3 and 4. So for 4, go to 4 index, you'll be having 2, 2. Go to 2 index, you'll be having 1. Go to 1 index, you'll be having 4 again. So this path length is 3. But we still have one element need to be explored. So 3, if you go to 3 to 3, the length is 1. So basically there are P1 and P2. So 3 and 1. So we are having only 2 paths. So merging these 2 paths will take how much cost? 3 plus 1, it will take 4. So finally have merged into one path. So the cost is 4. So I hope you guys understood. So each time what we have to do? So when you're having 1, 2, 3 and 4 for this example, so when you found the lengths of all the paths, we have added into some data structure. So always we need to pick the 2 minimum values. So 1 and 2. So I'll add 1 plus 2. You'll take 1, you'll take 2. You'll add 1 and 2. You'll add it to the cost. You'll get 3. And again you will add this 3 into this data structure 3. Now again I'll take 2 minimum values, 3 plus 3, you'll get 6. Add 6 to the cost. And again insert this 6 into the data structure 6. So again you'll remove 4, you'll remove 6, 4 plus 6, you'll get 10. Add 10 here, again insert 10 here. So we have to repeat this process until we are having only one element in this data structure. So always we are picking the 2 minimum values. So which data structure is suitable to perform this? So if we use min heap, always if my length of min heap is greater than 1, then I will pop 2 minimum values from the min heap and I will add it to the cost, again add that value, return into the min heap. So we'll keep on repeating this process until we have one element in the min heap. So that again we'll return the cost as our answer. So let's try to implement this. Let's try to write the code for it. Okay, let's code it. So I'll be given t test cases. So in each test case, you'll be having size of array and array elements. Let's take size of array. Okay, so after reading the input, so first we need to generate the lengths of all the paths in the array. So what I'll do is I will iterate over all the elements in the array. So first I'll check whether that element is explored or not, nothing but if that element is present in any one of the path or not. So to check that, I will maintain one hash set. If the element is explored, I will add that element into the hash set. So first I'll check if that element is not in hash set, that means we need that element is not included in any one of the path. So we need to generate the path and we need to get the length of that path. So what I'll do is I will write one function generate path which will take array, and I'll pass the index for which element I need to generate the path, and I'll also pass a hash set. So this generate path will return the length of that path. So with the starting of that element, it will generate the length of that path and it will return that length, and I will add that length into the min heap. I'll take one more list. Let us assume it as a min heap, and I will add the element into the min heap. So once I've got lengths of all the paths in the min heap, so first to convert it into the min heap, I need to import heap queue. So using this heap queue, I need to heapify, so it will convert into the min heap. So once I have done it, so first I'll check that once I have generated all the paths, first I'll check if the length of the min heap is equals to 1. What does it mean? No need to merge any paths, so we can directly print 0. So if length of min heap is equals to 1, not 0, 1, so we can directly print 0. Else what do you need to do? So I'll declare a cost variable to store the cost. So each time I need to check if length of min heap is greater than 1, then I need to pop the minimum 2 elements from the min heap. So how can I pop? Heap queue dot heap pop, and we need to pass the min heap C1 and C2. So heap queue dot heap pop min heap. So I will add this cost. So cost equals to C1 plus C2. So I will add this cost to the min heap again. After adding this path 1 and path 2, whatever the new path length generated, we need to add it into the min heap again. So heap q dot heap push min heap dot comma C1 plus C2 new cost new length. So we have to repeat this process until we have one element in the min heap. Finally print the cost. So now we are left with generating the path length basically. So I'll write a function generate path. It will take array and index, from which index we need to generate, and along with this we also have hash set, because once you have explored that element, we need to add that element into the hash set. So I'll take x equals to I while a of x not in hash set. Then what I'll do, I'll add hash set dot add that element a of x. After adding that element, we need to go to first initially I is an index. I'm checking whether that element is present or not. If it is not present, I'll add that element. I'll increment the count because we need to know how many elements we're exploring in that path. So initially C is 0. Once I've done this, again I need to go to the index of that element. So x equals to, now the index will be changed to element in that index. So a of x minus 1, because in the array it will use 0 based indexing. So I'm a of x minus 1. Finally return count. So hope we are done with it. Let's run it and see the sample test cases. We need to get 0 and 4. Okay, so for this example, length of a, or we can simply write it as n value. So for this example, we need to get the answer as 19. Let's run it. Got it. We got the answer as 19. Let's submit and check. Done. It is accepted. So the time complexity is t into n log n. So which will be get accepted. If you like this video, please consider liking it. Also share it with your friends and subscribe to our Smart Intelligence YouTube channel for more such content. Thank you.